Good. All right, good morning, everybody. It is Monday, March 1st. Yay. Lesson 11, we're going to talk about factoring expressions today. So for those of you that are learning from home today, you kind of missed what we just did in class, but I'll show you what it looks like on paper. Use the model to answer the following questions. You'll notice there are 2 5s here and 2 3s, exactly what we were talking about. How many 5s are in this model? Alexis? How many 3s are in the model? What does the expression represent in words? So we're going to write this in words. 5 plus 5 plus 3 plus 3. So 5 plus 5 plus 3 plus 3. Or we could write 2 times 5 plus 2 times 3, right? So we just kind of talked that out a few minutes ago when we had people in front of the room. Again, still here we have 2 5s and 2 3s, just like before. How many 5s? How many 3s? But this is when we rearranged it. We went 5 plus 3 2 times. And if we write it like an algebra expression, it's 5 plus 3 2 times.
Why is the on the top? Why is the 5? Oh yeah, it's times. I forgot.
Yep. All right. So the gist of this whole thing is the gist of this whole thing is that this is the same as all those like expressions are considered equivalent. We took the same numbers and the same values and we just wrote that in different forms. You could do the expanded form where you write everything all the way out. We could say 5 times 3 plus 3 times 3, or we could say 3 plus 5 2 times. But they're all going to give you the exact same answer. That makes sense?
Yeah.
Okay, so here's the big question of the day. What is the name of the property that is used to say that those two things are the same? And I don't know if you guys remember this or not. We did talk about it during Module 2, and you should have talked about it in 5th grade. It's on the back board. See where it says properties of numbers? Which one of those do you think it looks like? If you think about what we were just doing. Henry? Associative? Nope, there's no example up there to look at. Cooper? Nope, that doesn't look like what we were just doing. Michael? The distributive property. Look at how the distributive property looks.
It's exactly like.
Distributive property. Then we practiced it with letters, which we also did together. And so basically what we said was A plus B is the same as 2 A's plus 2 B's. Do you guys agree with that?
Yeah.
What about when we did it like this? A plus B 2 times. Does that make sense? So I think it's pretty simple. Now we've only done a little bit, so we're going to practice a few of these together. So we're actually all the way down on example 3 now.
This is a fast period.
I don't think we'll finish it all because we've only got about 17 minutes left.
What?
Okay. So I have 3 F's and 3 G's. So let's write out what that means if I have 3 F's and 3 G's. Ready?
Uh-huh.
Page 50. I know I'm skipping around, but I don't want you to have to do. There's certain things I think we can skip around on. So I have 3 F's and 3 G's. Is that going to be equivalent?
Yes. Yes.
I heard that. I have F plus G 3 times. So far, is it making sense?
Yeah.
All right. So here's what I want to show you, because this is where we're going to end up. So now that you see why they're all the same, I want to show you what kind of problems they're going to give us to do. They're going to give us a problem like 3F plus 3G, and they're going to want us to factor it. So who knows what the word factor means? Any ideas? If you factor something? Yep.
Put it in like a bigger form or literal form.
Kind of. Madison, what do you think? Well, let me show you this. If I factor out 12,
6, 6. Oh.
no, it's not 6 and 6. Yes, we're dividing it up. Right? That's a factoring. So what we're going to do is divide this up. Now, the only way we can divide this up is we have to find something that they both have in common that I can divide out. So looking at these two, do they have the same letter in common?
No.
Do they have the same number in common?
Yeah, I guess.
So we can divide out the 3. So watch what happens when we divide out the 3. The 3 ends up on the outside of the parentheses. Now, do you remember when we said fractions are division problems?
Yeah.
So I'm going to divide these by 3. Watch what happens. Those cancel out,
Yeah.
and those cancel out. And what's left is F plus G. Yes.
Could you do it the other way? Like, we do more F plus. Can you do F times 3
Yeah.
times?
And 3 times F and 3 times G is right there. Yes. Okay. Go practice a couple more of these. I'm not going to fill in all these spaces, so let's just have a work area over here.
Okay.
So the first thing we're going to do is we're going to look at the letters first, because if the letters are the same, it makes it super easy. We just take out the letter and you're left with the numbers inside. In this case, we don't have the same letters, so I have to look at the number 6, and 9 and say, what can I divide out of both of those that's the same number? The same number goes out of 6 and out of 9. Maya? Exactly right. So the 3 ends up on the outside of the parentheses. Now let's go divide both of these by 3 and see what's left behind. 6 divided by 3 is what? 2x. There's the plus sign. And 9 divided by 3 is 3y. And so you're left with 3 times 2x plus 3y. Let me show you another reason why that's true. I'm going to write 6 x's. And then I'm going to write 9 y's. And I'm going to divide these up into groups of 3s. Or 3 groups. 3 groups of, I'm going to divide them into 3 groups. Ready? So for the x's, to get 3 groups, I'm going to put 2 in each group. But for the y's, if I put them in 3 groups, look what happens.
They have an extra.
They do. So I have 3 groups of, what's inside each of these?
2.
2x. And what's in each side of this?
3.
Which is the same as,
How?
so basically what we're going to practice is how to rearrange those in different orders by factoring things out. So let's take this next one. What do they have in common? Henry? They have the letter C. So the C comes on the outside of the parentheses. What's left inside? If I divide out the C, I have 3 plus 11 left.
No, that would be 14 plus C.
Let's try this one. Do they have the same letter this time? No. So we got to look at the numbers and go, okay, what can I factor out of both 8 and 24? They can both be divided. Yes.
2.
Well, there's a bigger number than 2.
No. Oh.
Yes, ma'am. 8. Exactly. So what happens is the 8 comes outside the parentheses. And I divide it out of here. So watch this. Divide by 8, divide by 8, right? Fractions are division problems. How many 8s are in 24? There's the plus sign. And how many 8s in 8? Look at that fraction. 8 eighths equals what? 1. So what do you guys think? Here, here, or here? I'm good. This is kind of, I'm getting used to it. Oh my God, I've lost my mind. All right,
I lost my mind.
I knew that. I knew that. Okay, we're going to practice a few more. Feel like we're going to get you guys feeling a little more comfortable. Over here, we're going to use our workspace. What do they both have in common that I can factor out? Bailey? Yes, so I'm going to take out the 7 on the outside of the parentheses. And what's left behind? Madison? Oh, I'm sorry. I didn't know you were. Okay. If I take out the 7 from here, Lily, what do you think? If I take out the 7 on both of these, what's left behind?
X and Y.
X plus Y. Well, I've got a G and an H, so I can't deal with the letters, but I can look at the numbers. I got 15 and 20.
Racial T.
Both be divided out by what, Isaiah? 5s. Take 5 on the outside of the parentheses. Watch what happens when you divide both of those by 5. How many 5s in 15, Cooper? And how many 5s in 20, Cooper? What do you think? Make sense?
No. I'm in the negative sign.
Shh. I got M and N, so the letters are not going to match. So I have to look at the numbers, 18 and 42. So when I get to bigger numbers where I got to think a little bit longer, I always look at the smallest of those two because this is going to have fewer factors than this. 42, because it's a bigger number, is going to have more factors. So look at 18 and go, well, the only ways I can get to 18 are 2 times 9 or 3 times 6. I want the biggest possible number. So start with the biggest one. Will 9 go into that evenly?
No.
What about 6?
Yes.
Yes. So I'm going to divide out a 6. So the 6 comes on the outside. I'm going to divide out a 6. How many 6s in 18, Bailey? 3. Yep. And how many 6s in 42?
7.
There you go.
I think.
We're going to skip over D because I don't have enough space.
Me either.
11F plus 15F. What do they both have in common? Nope. The letter F. Oh, I'm sorry. Did you say that? The letter F. I'm sorry. I didn't hear you. So we're going to take the letter F on the outside. What ends up remaining behind, Isaiah? What would go inside? Yep, 11 plus 15.
26.
18H plus 13H. What do they have in common? Alexis? So we're going to take the H on the outside. Angel, what ends up in the parentheses? What's left behind? 18 plus 13. I think we'll have time to do 2 more and then we're going to quit till tomorrow. 55M plus 11. So I can't, they don't both have the letter M. So I got to look at 11 and 55 and say, what can they both be divided by? Bailey. 11, exactly right. 11 is on the outside of the parentheses. And when you divide them both by 11, how many 11s in 55, Henry?
5.
And how many 11 11s equals what?
122. That's correct.
He's not used. Give him the paddle.
I'm going to get some mashed potatoes.
I'm about done.
Okay. 7 plus 56Y. There's not a letter in common. So we have to look at 7 and 56. Yes? Henry? They are.
No.
You guys remember the trick? Did I ever show you this? Write down 5, 6, 7, 8.
Wait, hold it.
56 equals 7 times 8.
Wouldn't it be easier with 8 than 7?
5, 6, 7, 8. That's how you can remember. 7 times 8 will be 56. So we're going to divide them both by 7s. So 7 comes on the outside of the parentheses. Divide them both by 7. 7 sevenths equals,
122.
and how many 7s in 56?
80.
Riddick, please stop.
But wouldn't it be easier
Please stop.
with 8?
You can't because 8 doesn't go into 7 evenly. You have to use the 7. Okay, we're gonna do one more. I lied. Think we got time. No, we don't. Yes, we do.
No, we don't. No, we don't.
No, we don't. So here's what you have to do. Put this in your book bag for tomorrow. Don't lose it.
I know.
I will.
Open up your composition books.
Google will probably drop it off the roof. Yeah, Cooper drops his things off this roof.
I dropped my whole book down.
Right here, guys. Today's date is on the board, March 1st. And I want to make sure you write down the property that we were talking about, the distributive property. And we're going to write an example of what it means. And this is kind of what we were doing when you guys were standing in front of class. Okay? We had something times the quantity B plus C. And to get the second form, you go A times B, and then the plus sign, and then A times C, and I'll just put down, we'll use the exact same example that we did in front of class. We had 2 times the quantity 3 plus 5. Remember those?
Yeah.
So we had 2 times 3 plus 2 times 5.
We never did 2. Did we? Okay.
Okay, you guys can close this up. Have I volunteered to wash tables today?
Dimmy, I never do
Cooper.
it. Cooper, why do you always put that in?
Lily, can you explain to her how we take, what we're doing just to pack up? Okay, guys, keep that for tomorrow.
Hey, when is February 23rd? That lost out of my book and went into my math notebook.
I don't know. Probably have to take it back to the library, I would guess.